Welcome everyone. Now let's talk about the logical and bitwise operators. And we will also do practices with one of the logical operator known as logical AND operator. So there are 5 logical operators. We have the logical AND, bitwise AND, logical OR, and bitwise OR. And lastly, we have the logical NOT operator. It's also the one that we have talked about before. Every time when you apply this operator, it will return you the opposite. Okay, and those logical operators and bitwise operators, they can be used in the conditional statements, which you will learn them very soon. But for now, let's talk about what happens when we use those logical operators. We will start with the AND operator, the logical AND and bitwise AND operators. Here's the truth table of the logical AND and bitwise AND operators. So we could use this logical AND and bitwise AND operator to combine 2 Boolean expressions and then to get one Boolean result at the end. If the both expressions are false, it returns you false. If one of the expressions is true but the other one is false, it will still returns false. And if one of them is true, the other one is false, then our output is still going to be false when we use this AND operator. The only time that the logical AND and bitwise AND operator will return us true would be when both of the expressions are true. So when you use this AND operator, doesn't matter if it's a logical AND or bitwise AND, there are 75% chance that you will end up getting false. The only times that you will get true is if both expressions that you give with the AND operator are true. Then you will get true. So this logical AND operator is mostly used whenever we need to create the conditions that includes the terms such as both. If both conditions are met, then it will return true. Otherwise, it will return false. And you should also know the difference between this AND and logical bitwise AND and logical AND operator. The logical AND operator is the one that is used a lot when it comes to the conditional statements due to its ability to support the short circuits evaluation. But the bitwise AND operator, it does not support the short circuit. The short circuit means you see, in the AND operator, when you use the AND operator, as long as one expression is false, your final result will be false at the end, right? So if I'm using logical AND operator, if the first expression is false, compiler does not need to check the second expression. There is no need to evaluate the second expression. That is known as the short circuit evaluation. Okay? But if I am using the bitwise AND operator, if the first expression is false, the second expression still has to be evaluated, even though the final result is still going to be false at the end. Okay, so that is known as the short circuit evaluation. If one expression is false in the logical AND operator, final result will be false. No need to check the second expression. With the logical AND operator, there is no need to check the second expression if the first expression was already false. But when you use this bitwise AND operator, even though if the first expression is already false and final result at the end still going to be false, but it will still evaluate the second Boolean expressions that you give. So this AND operator, it always evaluates the both expressions before returning an answer. Here are a couple more examples of the bitwise AND and logical AND operators. If you look at here, in the first print statement, we are comparing the variable num with 1. Num less than 1, 0 less than 1 gives us true. Since this is the AND operator, both expressions must be true in order to return true, so we still need to check the second expression. Num equal to 0. 0 equal to 0 is true, therefore it will give us true. Okay. And when you use the logical AND operator, if you give the same expression, since both of them are true, at the end it will still returns true. And when I use the logical AND operator, if the first expression is true, there is still chance that the second expression could be false to return me the false result at the end, right? If the first expression is true, still it will check the next expression. 0 greater than 2 will be false. So as long as one of them is false, then it's going to return us false. Okay. And now, when you are using the logical and when you are using the bitwise AND operator, which includes first condition as false, and when you are using the bitwise AND operator, if the first expression is false, this bitwise AND operator, it still needs to evaluate the second expression. Even though final result is going to be false at the end, it still has to evaluate it. It does not support the short circuit evaluation, right? But when you use the logical AND operator instead, the moment that this first expression 0 greater than 1 is evaluated to false, there is no need to check for the second expression. So it's more faster compared to the bitwise AND operator. Okay, so our expression here will be, since first one is false, the final result will be returned to you, and it will return you false. You see, second expression won't even be checked. That's why this logical AND is the one that is used a lot in the conditional statements, because of this ability to support short circuit evaluation. And let's also write them in the IntelliJ to analyze them one by one to see what's happening each time when we are using the bitwise AND operator and the logical AND operator. Please create a new class under this package module 13. Name it AND operator. Okay, here's our class, and let me create my main method. Suppose that here I have this number is equal to 100, and let me use the bitwise AND operator first. So I could use this bitwise AND operator to check two Boolean expressions. I'm going to give my first Boolean expression here within this parenthesis, and second Boolean expression in the second parenthesis here. This is the bitwise AND operator. Okay, and in the first Boolean expression here, I'm giving a greater than 0, and in the second Boolean expression, let me give a less than 200. Okay, so a's value is 100. 100 greater than 0. 100 greater than 0 is true, right? And then we have this bitwise AND operator. So bitwise AND operator, it must evaluate both operands, both Boolean expressions all the time. Okay? And our second Boolean expression here is a less than 200, which is 100 less than 200 is also true. So if both of them are true, then at the end, our final result will be true. Okay? And what if one of the expressions is going to be false when I use this bitwise AND operator? Suppose that here I have this expression a, which is equal to 200, and a does not is greater than 50. Suppose that I have this Boolean those two Boolean expressions that are combined by using this bitwise AND operator. Okay. So a's value is still 100. Is 100 equal to 200? No. So therefore this expression here is false. Based on the truth table of the AND operator, as long as the first expression is false, final result will always be false, right? As long as there's one expression out of those two Boolean expressions are false, then final result will be false at the end. But since you are using this bitwise AND operator, it has to evaluate both expressions. So which means even though the result is still going to be false, it still has to evaluate the second expression that we have, which is 100 greater than 50. It is true, right? And then it will return us false at the end, because based on the truth table of the logical AND operator, if both of conditions are true, that's the only time that we get true. Otherwise, we get false. Since not both of them are true, we are getting false right now. And what if I replaced it with the logical AND operator? Instead of bitwise AND operator, let's say this time I'm using logical AND operator. Okay. So in this logical AND operator, first let me give this expression a less than 1000. And then here's my logical AND operator. And second Boolean expression, I'm going to give a greater than negative 100. Okay. So A's value is still 100. If it is 100, let me give 1000 here. Is 100 less than 1000? It's true, right? It is true, okay? So even when you are using this logical AND operator, in order to get true at the end, both expressions must be true. If the first expression is true, this operator, it still needs to evaluate the second expression in order to return true. If second expression is also true, then our final result will be true. So A is 100, 100 greater than negative 100 is also true. So now our final output here is going to be true. Okay. So if I run the program now, as you can see here, we got true on the console. Okay. And what if I give one false first expression as false when I'm using this logical AND operator? Suppose that here I have this first expression, which is A less than 0. And the logical AND operator is placed. And then the second expression I have is A is greater than 0. Oh, well, let me use different number this time. Greater than 20. A's value is still 100. We haven't reassigned this variable A yet. So if A's value is 100, is 100 less than 0? This Boolean expression is now evaluated to false. Okay? And then we have this logical AND operator. You see, the short circuit evaluation means the moment that the first expression is false when you are using the AND operator, when you are using the logical AND operator, then final result will be false. There is no need to evaluate the second Boolean expression. Only with this logical AND operator, okay? With the bitwise AND operator, if the first expression is false, you would still have to evaluate the second expression. The second expression still needs to be evaluated. But when you are using the logical AND operator, the compiler will not evaluate the second Boolean expression. It will just returns false at the end. Okay? So this is known as the short circuit evaluation. It works with the logical AND operator. So that way it's going to be more faster. Compiler does not need to evaluate the second expression in this case. Where in the bitwise AND operator, even if the first expression is already false and result is going to be false regardless, the bitwise AND operator, since you are using bitwise AND operator, compiler still needs to evaluate the second Boolean expression before returning false. Okay? This is the one that we will be using more often when it comes to the conditional statements of Java. Okay? Thank you so much, everyone. See you all in the next video.